The starting point is the semantic kernel's kernel object, which is used to create the Ollama chat completion extension, wherein I pass the Ollama model, and that Ollama model is something which comes from my hosting the Ollama in my local machine, which is running on 1144. Come and hit here, wherein it is trying to get the generate dictionary suggestion async. We are passing the destination, the days, and the user preference of adventure, and all these into a prompt, and the prompt is going to chat completion service. Now as you see, it has returned the result, and as you see, it is loaded in the UI as well. Hello everyone, welcome back to the 5-Minute Tech channel. Today we will be talking about how to build an agentic AI app with semantic kernel and C#, and in this we will be implementing an agentic app for a travel planner, and with this we will be using a Blazor server UI, ASP.NET Server Web API, and the semantic kernel for the business logic. And we will be having SQL Server EF Core for saving the data, and the semantic kernel's Ollama connector will be running on the local model Llama 3, and that will be our AI layer. So let's get started. Now, first of all, we need to understand what is AI agents. The definition of AI agent is that software entity that process information and makes decision and can take actions and operate autonomously or semi-autonomously. The type of AI agents here include reactive agents, deliberative agents, hybrid agents. The reactive agents being able to respond to inputs without memory. Deliberative agents use reasoning and planning, and the hybrid agent combines reactive and deliberative approaches. Now, comparing agentic AI versus traditional AI models perform specific tasks which it is asked about, whereas agentic AI adapts, learns, and collaborates to get to the answers. Moving on, we have semantic kernel overview. So what is semantic kernel? Semantic kernel is a framework for building AI powered application. It helps you combine more than one AI agents or AI models to get your answers. It enables modular AI components that interacts with APIs, databases, and other agents. So it's a combination of different functionalities can combine and give you a result rather than a single 1:1 model collaboration. The key features includes AI plugins. It extends the functionality with external APIs and memory and context awareness. Agent retains information across the interactions. And then multi-agent collaboration, where agents work together to solve the complex problem, wherein you can combine more than one agent, maybe a Llama 3 and OpenAI, and all those things you can combine. Why use semantic kernel? Because you have you want to support scalability. It supports cloud and local AI models. It has the flexibility of working with OpenAI, Ollama, and custom models as well, and also interoperability, where it integrates with existing enterprise systems to give you the result. Next is AI agent lifecycle. Now, when we work with the AI agents, it has different stages. First is the agent initialization, where it loads the instruction and the context. Then it connects to the AI model, which is something like an OpenAI or Llama, and the processes the user input which the user provides, and it passes the query using the natural language understanding, retrieves the relevant data from the memory or the APIs, then makes the decision, uses reasoning model to generate responses, adapts based on user feedback. So if you ask questions one after the other, it will adapt to the answer to your inputs. And then the action execution, wherein it sends response to the users and triggers external API calls or workflows. Now we have a place where we can do a multi-agent collaboration, wherein you have a Llama-based agent, OpenAI-based agent, and they both can collaborate to give you a proper response. So how does the agents work together? They do a task delegation. Agent assigns subtasks to specialized agents, and then the data sharing. Agents exchange information for better decision making, and then the human agent interaction, wherein the user guides the agent, which agent will give what answers and all those things through feedbacks. Example use case be your travel planning, as I will be demoing it now, wherein one agent suggests destination, other books the hotel, and the customer support, wherein the AI agents handles inquiries, escalates complex issues, and enterprise automation agent coordinates a workflow across departments. Now, memory and context awareness is very important area wherein you need the agent to remember what you asked before so that your subsequent questions will be related to the previous question you have asked. So why memory matters: enables personalized AI interaction, allows agent to retain past conversation to give you a better answer. And then the types of memory in semantic kernel: short-term memory is there, long-term memory, and then vector-based memory is there, through which it collaborates with your previous questions and tries to give you answer in line with what you have asked earlier. And then we have application of memories where you have personalized recommendations and contextual responses and adaptive learning systems. So all these can be built into the system for awareness. Now, running locally with Ollama, what is Ollama? We have already had a video wherein we have talked about Ollama in length and we have done an implementation. So Ollama is a local AI model running for LLMs and SLMs, and enables offline AI processing. Benefits from your local AI agent: you can install it locally and run the Ollama locally in your system. Privacy: there is no external APIs, so it will run in your system yourself. It has a faster performance, and the customization can be done wherein you can fine tune the models for specific tasks. Now, the semantic kernel plus Ollama combination. Generally, semantic kernel also works with the OpenAI, but with Ollama you support the local AI for reasoning, and it works with the custom AI model. So we are going with the semantic kernel and Ollama combination. So this will be our architecture overview. We have the different layers in the application. The front end would be Blazor. It could be the Blazor WebAssembly or the Blazor standalone app, but basically it is a Blazor. And then we have a backend wherein we have C# and semantic kernel. We are coding into C# language using the semantic kernel library, the kernel library, and the AI agent layer wherein we are using semantic kernel working in integration with Ollama to do those chat completions where you are asking a prompt and it's trying to give you an answer. And then the database, if we need, we will be using the SQL server. So there will be a flow of HTTPS call from the UI to the API layer, which is the business logic is there, and then the chat completion will be called, wherein the agent will be getting us the appropriate answers, and it will write and read to the SQL server. To start with, we have a blank solution added, and this is a travel planner solution. To this solution, I'll go ahead and add different projects that includes class libraries, the web API, and the Blazor client UI. So I've added the travel planner API, the application layer, and the domain, the infrastructure, and the Blazor client. To start with, we'll begin with the domain. In domain, I have added the entity, the user entity, and then the trip entity, destination, the itinerary item, the expense, and the different types of itinerary item types. I'll go ahead and add the code for the infrastructure, the travel planner infrastructure now. So in the application, the travel planner application infrastructure project, I have added the different dependencies. The dependencies being your identity framework core, entity framework, SQL server tools, and the semantic kernel 1.58, and then the connector for the Ollama, which is 1.58 alpha. Now this is pre-release, include pre-release checkbox you have to check to get this. It is a pre-release version. The project dependency being your domain project. Now the main part which comes in here is this class wherein I have the Ollama AI service. The starting point is the semantic kernel's kernel object, which is used to create the Ollama chat completion extension, wherein I pass the Ollama model. And that Ollama model is something which comes from my hosting the Ollama in my local machine, which is running on 1144. So if you see this, to get this specific Ollama to be running on this, you need to install the Ollama. You need to be coming to this site wherein you can go to ollama.com and download for Windows. Once you download and install this, you will have to run a specific command. And the command which you have to run is Ollama pull Llama 3, which will pull the Ollama version, the Llama 3 version into your machine. And then you can see the the model you have in your system through Ollama list, and then you can do Ollama serve, or it will automatically be running onto your local host 11434, which you can check by this. Now once you have your Ollama running up and running on 114434, Then you can go ahead and do the basic configuration of setting the base address, and then you pass to the chat completion service the required iChat completion service which you have just injected into the system. Now this iChat completion service is coming from the semantic kernel, and it is taking the Ollama model and creating those HTTP connections to get HTTP client connection to get you the chat completion service. The chat completion service will give you the responses based on whatever prompt you provided, and the prompt creation is where you provide the details of all the properties which you will be seeing in the UI. We'll come back to this section again when we had code debugging the code. Apart from this, we have different repositories which we have getting all trips, add trips, async, delete, update, the basic CRUD operation. Moving on, in the travel planner application project, we have 4 different classes: the trip service, trip profile, and trip DTO. In this project, we have different dependencies: the auto mapper, the fluent validation. Then we have semantic kernel and semantic kernel connectors which we have for Ollama. Now this is required because we will be calling this through the trip planner service, trip service, and that service will be internally be going to the repository and saving those entries which we will be creating. Now there are other the things like auto mapper profile which we have created here, and the DTOs which will be working with the UI. So this is something which will be used to fill the UI model. And then we have the simple interface for the trip service which we have for the basic CRUD operation. Next is our API layer, where we have two plugins, plug in our client into the API project. We have to add certain dependencies. To begin with, we will have the database connections, the scoping of the interface repositories of the interface of the repositories with the implementation. Then we have the Ollama AI service which we just saw. It should be mapped to a particular interface because we are exposing certain methods here. So that is something which we are mapping in our layer here in the API layer. And then we have the auto mapper, and then the CORS policy, and that's the basic stuff here. Now in the controller, we have 2 controllers: the trips controller which will do the CRUD operation as we talked about, and the AI controller which will get the recommendations, itineraries, and everything. So we will be debugging to see what is happening here. Now in the UI layer, we will be, and to see the dependencies side, the packages which we have here is the JWT bearer for the validation. Then we have Unity framework which will be there for saving the data, and then the kernel, a semantic kernel, and semantic kernel connector for Ollama. Project dependencies will be of the application and infrastructure project, and then in the UI client UI application, I'll go ahead and add the code, and we can see this. So in the client UI code, we will have the dependency of the WebAssembly, which comes in with the when we have the Blazor WebAssembly, wherein we have different pages here. The base page will be your index razor, wherein we will be having the AI generate and the trips new, and then we will have the basic app razor is there, and then the home page and the AI generator, wherein we will be able to see or input the details, wherein we put a destination, we'll be putting the general questions and the start date, end date, and everything. Then the program CS will be having a call to the API, the travel planner API. So that's the basic stuff here. Here in the API layer, we have one more thing, wherein in the app settings we have mentioned what is the endpoint of the Ollama, which is this one, and which model we will be hitting. So this is this one, and then we will have the basic the DB and all those connections here. Now let's run this application and see how it works. So our application is up and running. We have 2 controllers, AI and trips. The questions which we will be asking will go through this AI layer, AI questions layer. So in the UI side, if you see, we have the AI assistant and your trips. We haven't created any trips, so we'll first go ahead and get the AI trip idea. So once we click on this, Let's go ahead and click on this. We will be getting a set of questions to generate the the itinerary which we want to go to. So let's try to put in some details here. Let me put in adventure. Here it will be beach, and the date would be 29 to maybe a week ahead, and then I will go ahead and click on generate suggestions. Once I go generate this generate suggestions, it goes to AI generator Razor page, and it tries to get, and when we go ahead and do an F5, it goes to the AI controller where it's trying to get the itinerary. And if you see, it will go ahead and hit the service here where we are traveling, asking the question here. So let me go ahead and do that. Before that, let me put a breakpoint here as well. So let me do the F5 here. So it will come and hit here wherein it is trying to get the generate itinerary suggestion async. We are passing the destination, the days, and the user preference of adventure, and all these into a prompt, and the prompt is going to chat completion service. The chat completion service is something which we have created above in the and loaded in the kernel, semantic kernel for the Ollama model. So let's run this. Now it's trying to load the data, and now as you see, it has returned the result, the content. So if you see the content here, and if I try to view it, it has returned the content with the result here of different places. And let's view this in the UI, and as you see, it is loaded in the UI as well, wherein the Goa travel itinerary, 7 days, day 1, day 2, and different days, and what all things you can do on different days it is suggested. So this is how you will be able to generate using semantic kernel. You will be able to use different kinds of models. I used Ollama along with Llama 3 model, and you can use OpenAI and others and combine the results and get the AI app to be working along with the multi-agent. So that was pretty much about this implementation. Hope you like the video. If you like, press like and subscribe to the channel. Have a nice day. Bye.